interfaces that work intelligently across multiple devices. And we'll focus on understanding the ideas and the architecture behind it all, what it means to build iOS apps so you can make the most of bringing your existing skills into the Apple developer world. Let's get to it. Before we talk about the apps we're going to make, let's cover what you need to have and what you need to know. And you need to have two things. First is a Mac running OS 10.10 Yosemite or 10.11 El Capitan. And if you're doing Apple development, it is a good idea to always be on the latest operating system. The second thing you need is Apple's Xcode installed on that Mac. And if you don't have it installed already, now would be the time. Xcode is free from the Mac App Store, and we need Xcode version 7. This course won't work with any earlier version. Now, depending on your software development background, you may expect to find multiple editions of your developer tools, a free version and also a pro version, or maybe an enterprise version, or perhaps even decide between competing code editors. It's not really like that here. Everybody uses Xcode. Okay, some people might use additional tools as well, but everyone uses Xcode. And there's no pro version, no light version, just Xcode. And one question you might have, can you do iOS development on a PC? Short answer, no, you need a Mac. Longer answer, still no, but before somebody writes in telling me how they managed to get a Hackintosh running on PC hardware, good for you, but you are likely to run into all sorts of issues and problems and kludgy workarounds. If you're going to do iOS development, use a Mac. If you don't have one, a lot of developers I know got started picking up a 2-year-old Mac Mini from Craigslist or eBay, and that's a much more pragmatic approach. All right, what you need to know. Well, here's what you don't need. Any background in iOS development. This is the fundamentals course, so I'm starting with the idea that this course makes sense if somebody has no experience developing in the Apple world at all. We're beginning at the beginning. If you do have any background in iOS or Mac desktop development, great. If you even know some Swift, fantastic. But if you don't, that's all right. I have a quick introduction to the language coming up shortly. But talking of languages, what I do expect from you here is programming experience, that you can already program in something like C#, Java, Ruby, Python, C++, and you are comfortable with the general ideas and processes of object-oriented software development. I won't be spending any time here explaining the difference between classes and objects or properties and methods. This is an iOS fundamentals course, but not a programming fundamentals course. I expect you can already write code and you know your way around a Mac. That's it. I realize there's a good chance you've created some iOS projects in Xcode already. Developers like to jump in. We like to experiment. But to begin appropriately, for a moment, let's pretend you hadn't. You're starting fresh. Xcode is newly installed, and let's go through creating that first Xcode iOS project. So, right into Xcode. And the first time you open it, you will need to confirm some additional dialogues. I'll choose the option to create a new Xcode project. We'll explore more about what a project includes in a moment. But like many programming environments, Xcode provides starting points, templates, for making different kinds of application. And because Xcode is for more than iOS development, it's also for OS X development and watchOS development, we have a lot of choices. So let's narrow this down. Every project we make in this course will be using a template under the iOS application section on the left here. And the most straightforward iOS template is the single view application, a simple iOS app with a single screen. Now, Xcode demands specific information when creating projects. It's picky about things being well named. Much of this information isn't that important right now, as we're just doing a demo, but Xcode doesn't know that. First, the product name. Basically, what's your app called? I'll say First iOS App. Next, the organization name. By default, it'll use the currently signed on username, but you could change this to a company. Whatever's here will be used to add automatic comments at the top of any new code files in this project. But the next one is more important. It's the organization identifier. Typically, it's your organization, your company's domain name in reverse DNS format. Now, Xcode doesn't follow this domain name. It doesn't check that you own it. So you could write whatever you wanted here, but it is required because this is combined with the product name at the top to generate the internal name of the application for this project, what's called the bundle name or the bundle identifier. Now, really, all this is for is just to make sure that if you ever did submit this project to the App Store, it's not going to clash with somebody else's project that also happens to be called First iOS App. So that's the naming done. Next, we make sure we get the right kind of project created. First is the language. We can choose Objective-C or Swift. It is possible to mix languages, have both kinds of code in a project, but we won't be doing that here. Everything in this course is Swift. Onto devices. Is this app intended for iPhone only, or iPad only, or universal, meaning both? Now, everything we'll do here applies to both iPhone and iPad development, but things will be simpler if we pick just one to begin with. I'll pick iPhone. Now, these three checkboxes can add additional functionality, additional code to our project. They're all great, but we don't need any of them, so uncheck all. Next, I get the option to create a Git repository, a source control for this project. Now, Git is fantastic, but again, we have enough to deal with iOS and Xcode and Swift, so we don't need this right now. In some programming environments, your projects must be saved in a particular location. Here, that's not important. I'll just save this to my desktop, and we get our new project in Xcode. Now, we'll explore Xcode's interface more in a moment, but in brief, on the left are the files that make up our project. We've been given a couple of code files that end in .swift, a couple of user interface files that end in .storyboard, and a couple of others. Single-clicking a file will open it for editing in the central section. Double-clicking that file would open it in a separate window. So I'll jump into the file called main.storyboard. This is our core iOS user interface canvas with this area representing our screen. I just see a lot of white right now. That's because I've got a reduced screen size. I'm going to click the button down at the bottom that can toggle this left-hand side on and off. And if I start to scroll around with my mouse, I'll see this central section saying View Controller at the top, and this is representing our first screen, what we're going to see when this application launches. As in many IDEs, Xcode has the ability to drag and drop user interface controls. Now, to do this, the right-hand panel of Xcode needs to be viewable. If you don't see it, there's a button up here on the top right that will allow you to toggle this on and off. Now, this section is split into an upper half and a lower half. What I'm interested in here is the lower half, and we want the third button. This is called the Object Library. And when it's selected, we're shown elements we can drag and drop. Some of them right now might not be that obvious, but towards the middle are some classic elements like buttons and sliders, and the one I'm interested in, which is the label. So I'll click this and drag it on. As I drag it, I'll push it up towards the top left. I'll see a couple of blue guidelines to help me in positioning, and drop. We get our first label. I can double click this to change the value. I changed it. I need to reposition it, but actually I want a larger font. Now, for this, I need to go back to that right-hand section of Xcode again, but for this time into the top half. And I'm looking at these icons at the top, looking for the attribute inspector, a way to change the attributes, the properties of an individual piece. And it's the icon that looks like the moving pointer on a physical scoreboard. This is the attributes inspector, and it's context sensitive, meaning it'll show the attributes of whatever is currently selected. I need to make sure my label is. If I had clicked off somewhere else on the screen, the attributes inspector, well, in this case, doesn't show me anything. So select the label again, and now I can go into that fourth button and change this up. I'll change it to, let's say, 36. I'm going to need to drag this wider again because the label itself has kept its original size. Let's run this. Now, when you download Xcode, you also get the iOS simulator that can emulate multiple models of iPhone and iPad. To choose one of those, I go up here to the toolbar in Xcode, to the right of my project name, where if I hover over it says Set the Active Scheme, and clicking this, I get a drop-down show up. At the top of the list is where I'll see any physical iOS devices I have plugged into this machine, but below it, the iOS simulator options to test different devices and resolutions. I'm going to select the middle-of-the-road iPhone 6 here. Now, to run this, I either click the play button on the toolbar, or the Xcode shortcut is Command-R. You don't need to do an explicit compile first. Xcode will do an automatic build if we need one, and you'll see the build succeeded message. The simulator will launch. If it's the first time, it may take a while to do that. Xcode will then install our app onto the simulator, launch the app, and should switch us from Xcode over to see it running. Problem is, I'm recording with a small screen size, so even though it's launched now, this is actually too big. I need to go up to the simulator menu, over to Window, and then I've got a scale option. I need something smaller. Let's try 50%. And there we go. We have our totally unimpressive interface in all its glory. Now, Xcode is still actually active over here. It's switched into debug mode. We could start analyzing the program, jump into the app, set breakpoints. But I'm just going to hit the stop button to return back to Xcode in its normal mode. Now, if you're like most programmers, creating your first iOS projects doesn't magically make everything clearer, often quite the opposite. It becomes apparent there's a lot going on here. And even the first few minutes usually brings up a lot of questions like, why is this user interface square? I haven't seen a square iPhone recently. What do the words view controller mean around here? What do these two code files represent? Do I need both of them, or could I delete any of this? So how can I, or how should I, add behavior? Where should we begin so this all makes some kind of sense? Well, let's talk about that. Some people like to learn a technology by just throwing themselves in at the deep end. They find a bunch of sample projects and just start tweaking and writing code, try and pick it up as they go. And that does work for some things. It doesn't tend to work very well here, because it underestimates the significance of what we're dealing with. Swift may be new, and iOS only a few years old, but this is all built on a long history of Apple development. Patterns and practices evolved over a couple of decades, and they're different from what you might be used to in .NET or Java or Python or Ruby or anything else. And those differences can manifest in everything from the smallest runway level specifics, like where do we write code to respond to somebody tapping a button, to the larger conceptual ideas that in iOS we'd use delegation in places where a Java developer would assume we'd use inheritance. So if you don't approach this with a bit of structure, it's likely to get extremely frustrating. And the way I like to describe it is that there are 4 distinct parts to this, 4 areas of iOS development we could independently explore and we could get better at. But you need to grow all of them for this to work. And if any one area is weak, this all falls apart. First, the language. Swift, brand new in 2014 with significant updates in that first year, giving us Swift 2 in 2015. A fantastic language with concise, great modern features. And we're also able to use it and need to use it to work with existing older Apple frameworks, many written in C and in Objective-C. But success in iOS will be not just from knowing the syntax of Swift. There's the second area, developer tools. Xcode. Now sure, it's a code editor, but that's almost the least important thing that it does. We'll need it to design user interfaces that can automatically adjust to multiple iOS devices, what's called an adaptive layout. We use Xcode for debugging our apps, unit testing, user interface testing. We can use it for data modeling and version control. It even includes 3D level editors and particle editors for game development. And when we downloaded Xcode, we also got the simulator. And we also got Instruments, which is Apple's developer tool for visualizing and analyzing performance. And those will all become part of our tool set. And separate from the first two is the third area, the architecture of iOS. And we know that the applications we're running here will run within a controlled environment. We can't decide how an iOS application launches or when it terminates. We don't choose how wide our screens are going to be. There's 1,000 other choices that weren't up to us. We're choosing to fit our apps into an existing architecture. Now, Apple could have implemented that architecture a dozen different ways, but they did it one particular way. So this includes lifecycle management. How do I react to somebody running my app for the first time? To what happens when somebody leaves the app? What can they do with an app in the background? We need to understand capabilities like what are the options for saving data on the phone? Can my app save to the calendar? Can it read from the contacts list? Can I use the camera or the accelerometer? Or in short, how can my app integrate with iOS? And part 4, patterns and practices, the important ideas and conventions that we work with. And that includes software patterns like model view controller, target action, and delegation. Many of these things exist in other technologies, but you'll find the emphasis is different. And in this area, I also include things like the human interface guidelines. What are the right kind of user interface controls to use in a particular circumstance? Sure, there is some overlap between the areas, but the benefit is being able to keep some kind of structure and a higher perspective as we go through this content. That as we circle around from one area to another, sometimes on a piece of Swift syntax, other times a feature of Xcode, or talk about when to use a switch, that it's not just detached pieces of information. This all fits into a larger picture. While we need this high-level perspective, we also want to keep things pragmatic and real-world. If you're watching this course because you have a specific app in mind you want to build, that's great. But if you don't, Well, even if you do, it'll be good for us to have a scenario here, some easily describable situation that will allow us to build an app that can start simple and get bigger as we go. So imagine this. A good friend of yours sends you a text. She tells you she got a new job. Awesome. Congratulations. Where? She answers, the Lookover Lodge Hotel. Ever seen The Shining? Do you mean that creepy hotel up in the mountains? She says, that's the place. Wow, what do you do there? And she answers, I'm the night porter. Our friend is the new night porter of the Lookover Lodge, the person on duty through the wee small hours of the off-season. She'll have a list of tasks to do every night. Things like check the gates, patrol the halls in the main building, go around all the cabins, check all the windows and the doors, make sure the pipes aren't freezing in the wintertime, respond to emergencies, watch out for creepy children in the corridors, etc., etc. We tell her we're learning iOS development and she asks if we can make a simple app for her iPhone. She wants a reminder list of all the tasks to do every night so she doesn't forget. Okay, we could ask her to use the Notes app, but that's not going to help us learn iOS now, is it? It's a hypothetical situation. Work with me. We're going to write an app called the Night Porter. It's going to start simple, just a list of tasks. Between you and I, this app is going to get bigger. We'll add basic behavior to that list, being able to change the colors for viewing at night. We'll then explore different controls to be able to fit more content and work with table views and loading in data. We'll take it from a read-only list and add custom interactivity to each option, supporting gestures. We'll add alert views. We'll use custom icons for the app. We'll cover it using adaptive layouts so our app works well on different devices. So that's our scenario. Okay, step one, we make the project. We'll begin by creating a new Xcode project, and once again we want the iOS Single View Application project template. Many of the settings here will be saved from the last time I filled this out in the previous clip. I'll call this new project the Night Porter. Make sure that it's using Swift as a language, that it's targeted at the iPhone device, and that these other options here are unchecked, and I'll go ahead and just save this to my desktop. If I go out and look at what was just created, I do get this Night Porter folder. And opening it up, I have a whole bunch of files here. Now, I said I'd talk more about what an Xcode project represents. And for right now, you can think of a project in two ways. Conceptually, a project is an application. We're making iOS apps here. So each app, whether it's the next billion-dollar idea, or it's just a simple one-button iOS app you're going to use to demo something and throw it away, each one will be its own Xcode project. And practically, on your Mac, a project is the way you group your related files together for that app. Code files, user interface files, assets like images or audio if you need it, whatever supporting data you need to include in that app. And very importantly, not just the files, but the settings that keep this project together. And those settings are what we first see when a new project is made. The settings describe everything from what version of iOS this app requires, whether this app should use landscape or portrait orientation, all the way to what developer account will this be associated with so that somewhere down the line we could publish it on the App Store. That's all included within the project and the project settings. But what we're most interested in first are the different files that we've been given. We've seen that we have a couple of code files, a couple of user interface files, and some other things. We'll add to this as we go. But I want to point out that there is a slight difference between the files that we see in Xcode and the actual files created on the desktop. If I go back to the Finder window, you'll see that they're close, but they don't exactly match. Particularly the folders look a little different between the two views. And that's because Xcode gives us a different perspective of our files, so that particularly when we get to larger projects, we'll have more flexibility when arranging them. And as a rule, when you're making changes to any Xcode project, you're adding files, you're deleting things, you're moving things around, you won't do anything using the Finder window. You'll do it all here directly in Xcode. And that leads me to the thought that now would be an excellent time to cover the basics of this application. As Xcode probably isn't your daily IDE of choice, at least not yet, let me take a few minutes to go through the basics, make sure the layout makes sense and that we're comfortable moving around in it. The main part of the screen is divided into three sections. The left and the right can be toggled on or off using the buttons at the top right here with the left and right highlights on them. That's all these buttons do. There is a third button that toggles a bottom section on and off. This is a debug area. As the name might suggest, it's most used when we're actually debugging our app, so we'll see this later when we need it. But the left and right sections we will use all the time. Now, unlike some programming applications, you can't rearrange the Xcode interface. These parts can be toggled on or off, and you can resize them to see more or less of them, but nothing can be moved around. Nothing can be detached and dragged and dropped from one side to the other. And there is a way to quickly understand the Xcode layout, because there's an order to this. It's a larger to smaller perspective going from left to right. The left side represents everything. The entirety of this project, the whole kit and caboodle. The middle is the one thing I'm currently working on, and the right is the one piece of the one thing. All right, I'll admit that's not the way Apple described this. They called the left side the navigators, ways to navigate, to get around our project. There are 8. They're selectable with the different buttons at the top, and we'll see several of them, but the most important is the first one, the one that looks like a folder. This is the Project Navigator, the view of all our relevant files. And one of the most useful shortcuts in all of Xcode is the shortcut to open this, Command 1. That will open the Project Navigator whether this section is open or not. The main middle area is, not surprisingly, for editing whatever part of the project is currently selected. If we click a Swift file, it's a code editor. If we click a storyboard file, it becomes a user interface editor, what's commonly called the interface builder. And if I select the very topmost icon in the Project Navigator, right underneath the buttons here, this switches to editing the settings of the project itself. Now, over on the right, the entire panel is officially called Utilities, but that name is not very useful. What we're more interested in are the 2 independent sections it contains, an upper section and a lower section, which each of those containing their own areas. Now, these upper and lower sections are very different from each other. The top section is the inspectors, ways to inspect, to view, and often to change the individual elements in our project, often down to the tiniest piece. That might sound a little vague, but that can be helped because the entire area here is context sensitive. It changes based on what you have selected. If I select a code file, I'll see 2 inspectors that I can shift between. But the difference is, if I then select an individual keyword in my code file, this is going to change to show me help for that word. But if I switch to a user interface file, say main.storyboard, this will change again and I'll get 6 inspectors up at the top. If I then selected something inside that particular storyboard, again, the inspectors are going to change. I'll see inspectors for just that particular element, maybe even just that label in that interface on that storyboard. Again, very sensitive to whatever you have selected. And the lower section on the right-hand side is a little easier because this one is not context sensitive. It doesn't change. This stays the same throughout this project. And this area contains 4 libraries. These libraries are collections of things that can be dragged and dropped into our project, like dragging and dropping a new code file into the project itself, or dragging and dropping a new button or a new label onto our user interface. And in iOS, the library you're going to use most often is the third icon here, the Object Library. Now, we also have Xcode's compact toolbar at the top. We've already used the play and stop buttons and seen this area over here that will allow us to connect to different iOS devices or choose different iOS simulators. The central section here is a status panel, and this will update to show different information as we edit our project, as we compile and run our application. There is a group of 3 buttons to the right of that. We'll use these to change the behavior of the main middle editing section, and we'll use this in just a few minutes. The final thing I want to do here is jump into Xcode's preferences. Now, there's a lot in the preferences. You can browse these at your leisure. I've made one change already. I just shifted to the presentation mode in the fonts and colors section so that my font is a little larger when I'm recording. I'm going to do one more thing, which is in the text editing section, I will turn on line numbers to make a few things easier to point out as we go through the course. But there are 2 things here I'd suggest you do if you haven't already. One is to go to the download section and preferences and start downloading the documentation for at least iOS 9 and for Xcode 10. Now, I'm getting a message here that the documentation requires authentication. What that's asking for is that over here in the accounts section, it wants me to log in with my Apple ID. Now, this used to be only worthwhile if you had joined the official Apple developer program, but now it's worthwhile even if you haven't, because when you sign in with any Apple ID, that's enough of an authentication that Apple will allow you to download that documentation, but importantly, it will also allow you to plug in an iPhone or an iPad, and you can then tell Xcode to test your apps on a real device. And that was something that was previously only available if you'd paid to join the developer program. You are still required to join the developer program before you submit anything to the App Store, and it makes life a lot easier when generating certificates, setting up beta testing, working with teams, that kind of thing. But if you haven't joined the program, I will leave it to you to peruse developer.apple.com for some of the reasons why you may find it worthwhile. So let's start adding some content to our project. We'll begin with a simple fixed list of tasks. For these first few minutes, we're not even adding any behavior. Into the project and into the file main.storyboard. These files describe our user interface. One storyboard can include multiple screens for an app and describe how we navigate from one screen to another, but we'll get to that a little later in the course. First, I need the object library, which is once more the third icon in the lower section in the utilities panel on the right. There are a lot of controls here. We're looking for a label. If you keep missing the one that you're looking for, you can use the filter box down at the bottom to type some text in and filter down to anything that matches on that. So I'm going for label. Drag that over. We will get the blue guidelines as we start to position it. I'll position it on the left, double click, add a little text. Now, by changing the contents, I did change the size of this. I'm going to reposition it there. Now, I want several labels, so I have a few options. I could just drag more on from the object library, or to copy this one, I could also hold the Option key, click and drag to create more. Notice that as I drag, I get more guidelines helping me line these up, not just with the edges of the screen, but also with the existing UI controls. Now, if I've started to drag things off and things are misaligned, know that just like most UI design applications, I also have options to select multiple controls. I'll drag around them, go up to the menu, into the editor section, and I'll find things like the option to align their left edges, make things a little bit easier. Now, if you're wondering right now, is he really just going to use a bunch of dumb label controls? Well, just for the moment, yes, because I want to demonstrate a couple of things that will happen, whether you're positioning simple labels or buttons or sliders or switches or more complex data-driven controls. So through the magic of editing, let me just quickly go ahead with setting the values on several more. I now have my initial list of tasks, but I'd like to go ahead and make the headings bold. So I'll select this daily tasks. With that, I can jump over to the attributes inspector, which is the fourth one. Again, very sensitive to what you have selected. And I'll change this from the regular system font to the bold one. Now notice that by doing that, I've changed the size of the contents of the label, and now I've got the ellipsis, the three dots, showing us this has been truncated, that the contents of this control are now too big for its boundaries. Now I could either manually use the handles to drag it wider, and that would work, but an alternative is to use the size to fit content option. If I go up to the editor menu, you'll see size to fit content, but also notice the shortcut, which is Command equals. And that will resize it to the exact size of the content. I'll do the same with weekly tasks. Go over here and in the attributes inspector, change that to bold, and I'll hit my Command equals to resize it and snap it back into place. Now, right now you might be wondering, could I have added one label and just written all the text inside it on multiple lines? Well, you can add multi-line labels, but by default they are only one line. That's a setting that you'll find again in the attributes inspector. And when you're editing a storyboard, one thing you'll have on the left of this section is an area called the document outline that can be toggled on and off with the button at the bottom here. This is a different perspective of the same content. It's a list of all the elements inside our storyboard. The same stuff, different view. It's not useful for visually arranging things. We'll do that over here on the visual part of our storyboard, but it is very useful to understand how things are nested, to be able to select controls that are very close to each other, because you can click any of these and see which ones I actually have selected on the other side. And very importantly, to be able to select things that aren't naturally visible over on this side of the storyboard. One example, a standard storyboard contains an element called the top layout guide. But there's nothing clickable in the actual visual part of the storyboard. However, if I click the top layout guide over here on the document outline, I will see the highlight of it showing here. So the more complex that our user interfaces become, the more important this document outline is going to be. And it's not just a case of needing one or the other, we will need both. But for the moment, let's just go ahead and test this. I'm going to go ahead and pick the iPhone 6s and just run. Once again, because I don't have an awful lot of screen size, I'm going to go to my window scale option and scale it down at 50%. I can see it loaded. That looks all right. I think my friend uses an iPhone 6s, but maybe I'm misreading that. Let me check and see what this would look like on the iPhone 5s. Select that one, press play again. It may take a moment just to reboot the simulator in a different mode. And when it appears once again, I'm going to change the scale that I'm looking at, which is 50%. Well, the 5S is a different screen size, and we're noticing a problem here. I'm losing some text. This label, or these two labels here, are too big for the display. And that is an issue. Here's the problem. There are multiple ways that we could deal with this. We could make the font smaller. We could make the label run onto multiple lines. We could truncate it. We could do nothing at all. Well, I'm not actually going to fix this for the moment. I'm not going to fix it for a little while. My purpose in showing that is to demonstrate that our storyboard, when we're looking at it here, is not an accurate representation of any particular iOS device, and nor does it pretend to be. And this is okay. This is intentional. While we may need to rearrange things a few times to make sure we see everything while testing, we're just not going to worry too much about that until a little later on. So if our interfaces look a little clunky for a while, that's okay. We will see several options for creating what are called adaptive layouts, where we can create one layout that will work across multiple devices and aspect ratios. But before we get there, let's see how to connect these user interface elements to our code. Our night porter friend has a question. Could we make the app have an optional nighttime mode using a dark background? The normal white one is fine most of the time, but if she uses this in the dark, it'll mess with her night vision. Well, that's our excuse to add some code. Okay, I'm in the storyboard. I'm going to open up the object library again. What I want is the button. Now, right now, I was filtering on LA to make sure I could bring up the labels here, so I do need to make sure that that's cleared out. And I find the button. I'm just going to drag it in underneath the text here, double click and change this to dark mode. In iOS 9, and this is the same in iOS 8, buttons don't have a visible outline. They're really just text. And I want to write some code in response to this button being tapped. In some programming environments, to write code for a button, you might double click it, you might right click it. Well, not here. In iOS and Xcode, here's how we do this. Now, I don't have a lot of screen space. I'm going to turn off my left and right hand panels first and make sure that my document outline is closed. I'm currently in what's called the standard editor mode. I mentioned that's these buttons up here. The leftmost one is the standard editor to allow me to edit one file at a time, just normal, just this storyboard. But the button next to it will switch me into assistant mode, with two files open at the same time, and we need to be in assistant mode for what I'm about to do. But these files aren't just any two random files. The point of assistant mode is that the files you're looking at side by side are related to each other. And this viewcontroller.swift file, which I can see at the bar at the top here, this is the corresponding code file for this storyboard. And this was all set up in the default project template we created. Now, all of this right now is just the default code we're given when we make that project. A Swift class called viewController and a couple of methods inside it. Now, I'm going to cover the basics of Swift in the very next module, but let's just jump ahead and write some. To make a connection from a control in our storyboard, whether that was this button or it's a label or a switch or a slider, here's how we do it. We'll hold down the Control key and click that button, and clicking and holding, drag over into the code. What should happen is you'll see the connecting line, and as I move up and down, it'll allow me to place code in a certain location. Now, what I'm looking for is this, the insert outlet action or outlet connection method. I'm going to do it right inside the opening curly braces here for me on line 12 and let go. I'll get a pop-up telling me that I'm making a connection. And I get a couple of choices of what kind of connection. We're going to get into this, but for now, just pick the one that says action. We need to give this a name. What we're saying here is we want the button to cause an action in our code, but we've got to name that. So I'm going to give it the name of change background. We could call it enable dark mode or whatever you want, and click connect. What this has done here is create a new Swift function for us to add code to. Well, it's inside a class, so technically this is a method. So I get the curly braces, and whatever code I add in here will be called when the button is tapped. So I'm going to add a line here. Say view.background color equals UI color dark gray color. Hit return, and this is the line of code that I want to execute. Again, I've got a zoomed in font here, so can't see a lot, but it'll all fit on this one line here. Now this may very well raise a few questions, but we haven't talked about Swift yet. For now, let's just test this. I'll go ahead and hit Command R to run it. It runs, we have the button, I click the button, and we switch into dark mode. Now, purposely simple and straightforward, but this method of connecting controls to our code by switching to assistant mode and then control dragging from a storyboard over into a code file, this is something we're going to do again and again. And sure, we want to add more interesting behavior, and there's a few things we need to talk about that just happened here. But first, we're going to have to talk about Swift. Unlike a lot of other courses, what we're trying to do here is not learn a little bit about 1,000 different things, but get the basics covered really well. So we began by creating iOS projects in Xcode and the importance of naming. We covered how to first think about the Xcode layout and that we find our way around our project, at least initially, mostly with the project Navigator. We can use the shortcut Command 1 for that. We can test our apps using the iOS simulator, selecting from different devices on Xcode's toolbar, and then running an application with either the play button or using the shortcut Command R. That we build the user interface in Xcode using a file type called a storyboard. And onto that storyboard, we drag items from Xcode's object library, and these individual elements can be configured with the inspectors, particularly the attributes inspector. But to make those UI elements connect with our code, we use the assistant editor, shifting into seeing 2 files at a time, and we control drag from the storyboard over to the code. And that in this simple project, the corresponding code file for our storyboard is the file called ViewController. And I talked about how to keep a perspective of learning iOS in 4 areas: the language, the developer tools, the architecture, and the patterns and practices. We ended with a little bit of Swift, and that's how we now need to continue.